Hello, hi friends. This is Satyam, and today we are gonna uh, learn something about USB. So, without any further ado, let me go to a slide. Mm. So here we go. Yeah. So today we're gonna talk about USB. So USB stands for Universal Serial Bus. It was introduced somewhere ago, 97. I'm not pretty sure about it, but it was kind of a joint project by giants like we have Intel, Compaq, and etc. Therefore, formed the community which is known as USBIF, that is Implementer Forum. They designed, implemented, and they still support USB. uh, I would ask you why we need USB. So before, like in traditional PCs, we have many serial lines, RS-232, and so many cables for different devices, and it was difficult for you know PC to recognize some of the devices, and it was way too slow, and there's neither a generic port, so they decided why not have a generic port which can support a lot of devices, and which in which user don't have to worry, so like you have some legacy port, then you have to worry for configuring it, setting the data and everything. So this was a big problem for user with no or with technical background, so they decided, like, okay, why not make a generic port for all the devices, and hence the name universal. And it would also be user friendly. That means user didn't have to worry about to configure and everything. So everything is bought by USB. So now typical architecture of a USB system is you have a root hub. So this kind of hardware. From that hardware, as we can see, you have many USB ports. As in my Mac, I have. Um, I don't know. Check it out. So I have one, two, and oops, I just have two ports. So in other devices, like you might have more than four or five. So how is this attained? You have a single hardware, and to that hardware you have hubs. So this kind of a network topology. So each hub can support devices. So in this architecture, you can see you have a root hub, then you have hub 1 and hub 2. In hub 1, there's one device. In hub 2, you are three device. So USB architecture, as I told you, it has some similarities with I2C. It is master slave protocol. It uses 7-bit address space, so that means to the power 7. So 127 devices from 0. So 0 is some special, I'll talk about it. So 127 devices can be connected. Now that is not the device, the address space is not mapped to the CPU memory or the IO space, so it doesn't consume much of CPU resources, as CPU is busy, so it doesn't have. One more thing, it has some similarities with PCI as well. So PCI stands for Peripheral Connection Interface. It was designed by Intel for chip-to-chip communication. Um, so it shares some features with PCI, like it is hot pluggable. You don't have to worry about anything. Yeah. So you have something called as pro function, disconnect function, ID tables, and all that. And they have their own DMA engines. DMA engines means like they can master the bus or send a signal, and so it supports multifunction devices. Oops. multifunction spelling is wrong. I'm sorry for that. Yes, I just misheard C. Okay. So these are two similarities that USB holds. Now, we heard of host controller. Now, what is host controller? Basically, you have device and you have host. So host is the master which initializes all the signals, it pulls all the slaves and so on. There is an exception, however, like for some of the USB device that are self-powered. So you know sometimes what happen in suspend mode, like device has to, like suppose your device is doing some transaction and later on you're not using it, so it goes to a suspend state. So once that is suspended, you know the host has to generate a wake up signal for the host controller to detect that it has something data to send, like you have network USBs and all. So at some time, yeah, you're using a modem, say for example. So it can be, in India we use NTS modem for internet connection. So whenever you have plugged in and you're doing some internet things, you're going to servers, you're browsing with pages and all, and at some point of time you don't want to do that, so you're doing with some other things that are offline. So if another person sends you a mail, so initially the ethernet device will be in suspended state. So once any packet comes, so it's kind of an interrupt that you know tells the host controller, hey, I have some packets, and the host has to acknowledge it. Now coming to next thing, how is USB connected to the CPU? So basically, it doesn't have direct connection to CPU. It has to go through PCI. So how do you find it? The best way to find it is, you know, you have a USB device. Let me set up for you. So as of now, I'm just connecting my mobile to my CPU. So let's see how my Linux operating system, this is a platform that I'm using, how it detects it. So here it goes. Yeah, so I have a screenshot. I'm using my VirtualBox. So let's say I want to connect to Linux. Now it got connected to Linux. Now if I go to terminal, it's not this. Okay, so and I type ls USB. Mm, there's some problem with my phone charger. So if I try ls USB, you can see that I've already recognized my device. My phone, that is iPhone 4, it has product ID and it has a Windows ID that has been created, and it is using bus number 1, and that is treated as device number 4. And this is my root hub, you can see. Then this virtual box hubs you have, and you have mouse and so on. So like it has one hub that is known as the root hub. Then that root hub takes care of your devices that are connected to your machine. Now if you go to, first let's see which PCI it is using. So if I do cat, oh sorry, if I go to logs, so let's go to logs first. It's log syslog. Okay, so here you might see, oops, I think I have to remove it and add back again. So you can see it has been removed from the surface entry. Now yeah, it got connected. Oops. So it's been a lot of up. So yeah, here's that. So you can see on the log message that I added default wired connection to this and come out of this. Let's go to the location that I copied. Mm. So here are the things that I've been using. So it's on USB 1. So it has some meaning. So it has, it is a root hub. So that's why it's USB 1. Then we have hub ports. Then that is connected to another hub. So that is will be there, and followed by semicolon we have configuration and interfaces. So here you can see, this is a root hub, and this is the port, next hub port, and this is the number of configurations I have. It has 4 configurations, and this has 2 interfaces. So this is how it gets connected to PCI. So it's using PCI, this, and this. So remember, so I'm not going to talk much about PCI. If you're interested in PCI, you learn about PCI, and you can see how, a chip-to-chip communication happens. It's now from host controller to the CPU. Okay, so this is the format you have to know. Now, moving on to next slide. There are some standards of host controller. So it is, I'm going to talk about there are many controller interfaces standards. So I'm going to talk about only 4 as of now. One is OCHI. It was developed by Compaq for USB 1.0 and 1.1. And you have Universal Host Controller. This was Intel's one for USB 1 and 1.0, but it required license from Intel, and it's for low speed and high speed devices. And ECHI is when, new generation of USB came into picture with high speed functionality, and which lagged by OCHI and UCHI, and it was implemented by USBIF. So basically this was a new thing for USB 2.0, and to have the backward compatibility, it has some companion host controller like OCHI and UCHI connected to it. So suppose you have USB 1.0 but your host controller is 2.0, don't worry, it's backward compatible, and because it has a companion controllers. Now how it detects, that's gonna be in our next tutorial, and we're gonna talk about it. Now you have something called USB OTG. So basically there was a concept like, devices can be connected to host, but through USB you cannot connect a host to a host. So it was a major thing. So the implementer forum came up with something known as on-the-go devices. Um, the on-the-go devices follows a simple rule: either one can be host, another can be device, or other can be host and device. It's kind of vice versa. If one is host, other is device, then other should be host and device. So it has an additional pin known as ID pin. So that ID pin, does some negotiation with the host protocol, and it works as a dual role device. Now basically, just very simple. Cables, you have V bus, D plus, D minus, and ground. D plus and D minus, as you can see, it's a twisted pair for basically high speed devices and full speed devices, but in low speed devices it might be a straight line. Now let's talk about some electrical specification of this. So USB has shielded cable that contains 4 wires, as you can see in your, USB plugs. So it has 4 wires and it has sealed. This Out of this, 2 lines are known as signal lines, that for D plus and D minus, and after that you have wires like ground wire, and the fourth one is P bus. Normally it supplies 5 volt, for device used for power. So suppose you have phone and you just want to have you know power line, so it will just supply you 5 volt. Okay. Now coming towards receptacles. Receptacles is nothing but how you're connecting your device. So there are many types of receptacles that USB had to offer. Those are A, B, and mini AB. So here you can see this is A receptacle, this is B receptacle, and this is mini B receptacle. Now don't go in confusion with mini B receptacle. It has 5 pins. The fourth pin is not connected, and I don't know why they did this. Maybe they thought of implementing OTG into it, but even I'm not sure. It can use OTG, but how? I still have to go through it. Now let's come to the power distribution. Now power is one of the main concern of USB because USB is kind of a zombie. It, you know, sucks. No, not zombie. I must say it's a vampire that sucks blood from your host. So it's a USB is a vampire to host because it consumes power. So and this is the most crucial thing. So you have something called as upstream port and downstream port. We're going to talk about it later. So as of now, just remember that device can draw 100 milliamperes and 500 milliamperes from VBus. For low speed devices, initially it takes 100 milliamperes of current, but for some hungry vampire, fat vampire, they need more blood, so it takes 500 milliamperes. Now coming to when you're not doing anything, so it cannot take more than 5 milliamp or less. It will be more nice. So as I told you, device requiring more than 500 are obliged to be self-powered. That means it has to take the power by initiating some signals or so and so. Now let's come towards transceiver. Transceiver is something which lies in between host and device. So it's a link layer. There are two types like upstream end and downstream end. Upstream end is nearer to the host or like to the root hub, and downstream is towards the device. So you have upstream and you have downstream. Upstream indicates device is following, and downstream means if you have any information that needs to be transferred to the USB devices. So here's a figure. Basically, towards left hand side you can see it's upstream. So it has both two pull-up registers of 15K. So what happens is when there is nothing, when there is no um, nothing going on USB port, so this 15K volt helps the transceiver not to send signal into it. But if you apply like in downstream and you have 3.3 volt on D plus or either D minus followed by some resistance, so this is typical to downstream. So why we have this is because uh, let's go to next slide. You'll come to know why you have 3K 3.3 volt that is passed to D plus, or I can say it can be passed to D minus. So basically it means mm, to determine whether your device is a full speed device or it's a low speed device. um, for instance, if your device is low speed, then D minus will be pulling this voltage from V bus. If it's a full speed device, then D plus will be taking into drawing the picture of taking the voltage. So this is a typical understanding of upstream and downstream end. So now let's come to line states. There are basically many states in the line. The simplest one are detached, attached, and line state. As I told you, detached state, the upstream transceiver that we have has 15 kilo ohms of pull-up resistance. uh, that puts the down low. That means, when you connect, when there is nothing, information going on your USB port, that means it's in detached state. Now in attached state, now hosts will find out, whenever you plug in your device, either one of your signal lines will pull the current from B bus. So that is known as attached state. Now ideal state um, is same as attached state, uh, for a particular time, like say for some not milli, microsecond. So anyone pulls the line low, there will be a transition in the graph, like, uh, so that will be ideal state. That means device has been ready to, initiate any transfers. Now this state of lines uh, is before and after a packet is sent. So whenever there is an idle state, then only we say, okay, device is ready, so you can send the signal. And we have something known as JK and single-ended zero. So J state, uh, uh, it's like it has the same polarity with ideal state, means any of the D plus or D minus are pulling the line up. So say for instance, like D plus is pulling the line up, so it's also known as J state. Now if D minus of the same device pulls a line up, that means it is uh, opposite polarity with the ideal state. You have something known as single-ended zero. Single-ended zero is the state. This all a terminology. The state when either D plus or D minus doesn't pull the line up from the V bus. Now you have something as reset, suspended, single-ended one. That is an illegal condition. Then you have end of packets and resume. So basically, reset state is whenever the device has been connected, the host controller will send a reset state so that it can initialize any transaction. Now suspend state is for make your vampire, lock your vampire so that it doesn't sucks more of the blood. So that what is meant by suspend mode. In this suspend mode, you use single-ended zero for about 10 milliseconds. So the device after 5 microseconds, it will know, okay, it has gone to the suspend state. Now if device goes to suspense state, it should have some, some protocol that sends resume signal, or start me off, I'm ready, I have something to send. So like for example, network. So if you're not using internet, immediately after some time you get a mail. So in that case, device has to send a wake up signal to the host controller stating that it has. So that state is also known as the resume state. And after start of frame or end of packet. Start of frame is something when the packet starts. We're going to talk about the packets more in brief later in the tutorial, next tutorial most probably. And end of packet is something means that the packet that has been sent from host or from device to the host, uh, there are no packets to be processed, so it sends EOP signal. So EOP state is helps us to determine the packet size, and when the packet is ended and when it's to be processed, proceed. And resume state, as I told you, after suspend state, it has to go to the resume state if device has or host has something for the device. So that's it for the first tutorial. Let me know if you have any doubts or anything. So I'm new to USB. This is a learning phase, and we're gonna talk more and more about it. So for this, uh, I took a lot of help from websites. So I found that this was one of the simplest approach to USB, as USB after this I didn't cover even 10%. So it looks something bizarre, something not like serial driver or TTYs, So it's complete bizarre. So let's see um, how it goes. And so thanks guys for watching this video. I'm gonna get